What's up, guys? Shawnthebro here, and today we're going to be going over some more wake-up mechanics. We're going to be going over rolling to get out of the knockdown state. So in the past, we had the ability to stand given a period of time where no input was pressed. We could also press the jump button or jump key to do a quick stand earlier than that to kind of throw off our opponent from when we were going to stand up. We're going to introduce rolling now by pressing left or right. So if I am to knock down my opponent, they are able to roll backward or roll forward based on the input that they press. Those are two different animations. I also want to show you we can do separate animations for wall bounces since our knockdown state is a little bit different. On the regular launch, the opponent, whoops, I mean to perform that command. On the regular launch, the opponent appears on their back. Opponent's going to get defeated here. But on this launch, off after the wall bounce, they appear on their stomach or chest. So we can actually have different animations for the rolls as well as a nice little touch for each knockdown state. Now, hard knockdowns actually don't allow the player to roll out of. So if I am to perform a hard knockdown, they'll be stuck in this state until the time is up. That's how I've designed it. That way, a hard knockdown is punishing, but it's fully customizable. It's up to you how you want to set it up. That's what we're going to be covering today. But if you'd like to get caught up in the series before we start this episode, you can click this icon in the top right corner right here. We're on episode 136 of the Fighting Game Tutorial series. We've come very far, but we still have a ton to do. I'm very excited to show off everything that we can accomplish in this series. Otherwise, if you'd like to just check out the knockdown stuff, we are going to use some of our logic from the previous episode regarding knockdown logic. So this icon right here is going to link you to the previous knockdown episode. That's where we initially set up the hard knockdown logic, separating it from the quick stand-up logic. Okay, and with that out of the way, we can go ahead and get started. So, we're going to have to touch a few things today. We're going to touch some things in code. We're going to touch some things in the animation blueprint. The first thing I'm actually going to do is just show you these animations because I do have 4 separate animations. So I have 4 different roles. They're actually all from one animation that I took from Mixamo, converted into a skeleton that supports root motion, just like I've done for all the other animations in this project. But I've chunked this one animation into 4 separate animations. That way we can determine which one we want to use based on certain conditions and the state that we're in. So let's just look at these real quick. That way we're familiar with everything going on. So I have mutant recovery roll, and then underscore, and they all have a name. So I have B, B2, F, F2. B is for backward, and the one without the 2, or just like B1 here, is going to be if the character is on their back. So if they received a regular launch and got knocked down. This is not the wall bounce. This is just the regular launch. It's going to play like this because I'm playing it in reverse. Okay, so backward, if they're on their back, they roll backward onto their feet. Backward 2 is if the character is on their stomach or chest. We play backward, they kind of push off and get back to their feet. Little difference, but makes it look better in the game by a lot, actually. Roll forward is going to play forward, and this is the standard, not F2. So this is when the character is on their back after a standard launch and standard knockdown. Roll up and onto their feet. And then we have F2, which is when the character is on their stomach or chest and they want to roll forward, having the character push off, immediately start a roll, and get back on their feet after. Now, none of these animations have root motion enabled. You could enable it if you'd like. Nothing wrong with that. There are going to be 2 methods to rolling, just like there are to dodging and dashing, like we've set up in previous episodes. So with the dashes, I implemented both root motion dashing and dashes with customizable distances and forces. we're going to do the same thing with roles. Roles in this tutorial are going to be a little bit different. They're going to have some different properties. We actually haven't gone over that yet, and we're not going to go over that in today's episode either. This episode is all about the actual tech for rolling when you're knocked down, when we can do it, when we can't, all that sort of stuff. We'll go over the actual roll logic and command roll logic in a separate episode. So you can decide however you want to set that up, if you want root motion or not. For me right now, I don't have root motion on these animations, so really the character doesn't get anywhere. They just stay in place. But like I said, we will cover that actual movement later. So just worry about these animations, making sure we get the right ones and that we're performing the proper logic, going to the right states. That's what we're caring about today. Okay, with all that out of the way, we can go ahead and start on the actual logic that we're going to be implementing. So I'm going to start in the code today. If we go to Visual Studio and go to Fighter Template Character, or our base character class, we have an enum called Combo State. So Combo State is an enum that tracks basically what state the character is in based on the environment around them. Okay, we have character state and combo state. So remember the difference. Character state is what the character is doing based on what the player has input and told the character to do. Combo state is the state that the character is in based on what has happened to them or what has happened around them that put them in this state. So running, crouching, jumping, all that is the character state, but being stunned, being bounced, launched, knocked down, that's all part of the combo state. So I've added 2 new enums today. Well, 2 new enum values within the combo state. And so I've added forward roll recovery and backward roll recovery. We already had recovery in here, and this is either if we choose to do a quick stand up or we let the timer run out and we stand up naturally after that amount of time. That is the recovery state. But the roll recovery should be different. A, they're going to have different properties when we continue upgrading the rolls in the future. But B, we want them to go to different animations, and judging on this combo state, we can decide what animation we want to go to. So I went ahead and added these 2 states to the combo state enum. Now, when do we want to trigger this and how do we want to trigger this? Before we look at the code, let's think about that logically. So when the character is knocked down, not hard knockdown, only regular knockdown, which I just switched away from it, but note that knockdown and hard knockdown are different states. Okay? So only when the character is in the knockdown state, not the hard knockdown state, are we going to allow them to roll in this case. And only if the character can move, we want them to be able to roll. So you could be knocked down, but you might not have any control over your character. In that case, we don't want them pressing an input to influence what state they go to next. So we want to make sure the character can move and they are in the knockdown state. And the way we're going to do it is if we press right or left, basically forward or backward, we're going to do the corresponding roll. That means we need to go to our move right and move right controller functions. Now these functions are pretty long and they can be a little bit confusing, I'm not going to lie, just because there's a lot in here. So follow along here. Now there's this first set of big if statements in move right and move right controller where we check to see if the player is crouching and check a bunch of values. We're not worried about any of this today. I covered all this in previous episodes, but what this is doing is this is checking to see if we should add the input icons to the screen. And it also tracks a little bit of our logic, like if we're holding back and pressing certain buttons and things like that. So we want to find this if statement. We can match up the bracket. We want to go as far as we can with that one, hit the else, and go past that as well. Once that bracket closes, you're going to run into another if statement here, where you go if can move, and you make sure that you're not in these certain states, and then you make sure that the combo state is equal to none. Right above that, so between those 2 if statements that I showed you, the first one and the second one, I've added this logic here. Everything highlighted, that's the only thing I've added, okay? So everything else you see in this function already existed. This is all I've added within the function. All right, so our first thing that we have to do is we have to make sure that our 2 conditions we spoke about earlier are true before performing this logic. So the first thing we need to do is check our can move boolean. Good old can move, just to make sure if we can move, then we do have control over the character enough to perform a roll from the knockdown state. Then the other thing that we care about is if the combo state is actually knocked down. Because if we press left or right, we don't want to just automatically initiate a roll. That wouldn't make any sense. We have to make sure we're in the right state to do that. So, if can move and combo state equals E combo state, E knockdown. Okay? And once we know this is true, then we have these inner three if statements. If, else if, and else. So we're going to do basically what you've seen throughout the rest of this function. We're going to determine if we press left, right, or a value that doesn't fall on either of those. Since this is the move right function, it gets called when the left key or the right key, or the forward and back key have been pressed, or those buttons have been pressed, I should say. And so it's running all the time, but if the value is not right or left, it's basically meaning that that button or that input has not been pressed, period. It's just a 0 value. All right? So to make things not confusing, essentially, if value is greater than 0.01, basically if the value, if the player is holding an input that is to the right or in the forward direction. Else if value is less than negative 0.01, that is checking to see if the player has pressed an input in the left direction, right? It's less than negative 0.01, or really less than 0 is a good way you can think of it. And so because of that, the player is pressing an input to the left. Else, no input was pressed, and we can go about our lives. So those are our three conditions. So we have something here at the start called has released right axis input. Now, this is for hold inputs. If you're not familiar with the series, it's going to be a little confusing when you see this. You don't have to add this or include this. It's not really important for today's episode. But to keep our logic true to the rest of the series, we do want to put this here. If you want to be able to charge an input coming from a roll, this is actually important to keep. So just to be aware of that, this could be useful. Also could be useful for performing double input, such as a dash immediately after. We want to make sure that if we have to press two of the same input, we keep track of this. So in this case, we want to make sure that we put has released right axis input to be false. Okay. Then we just check our direction to determine what direction we want to roll, what combo state we're being put in from this. So if we're not facing right, okay, if we're facing right, then we'll be looking to the right, and rolling to the right would be a forward roll. So if we're not facing right, we're facing left. So that is that's a backward recovery, because if we're holding right or pressing right and we are not facing right, then that is going against the direction we're facing, which is backward. Now, additionally, again, just like the has released right axis input here, we also want to keep track if we're pressing backward or not. This is important for certain actions and certain functions in our game. Also can be important, again, for charges and other things like that. So don't worry too much about this. Just if you've been following the series, we'll want to keep up with everything that we've done. We'll want is pressing backward to still be true, because we are pressing in the backward direction. It doesn't matter that we're in the knockdown state. We can queue inputs, we can buffer inputs, and so we need to know that we are pressing backward. It's mainly helpful for command logic, input buffer logic, right, to know that we are pressing backward. And so anytime we're doing it throughout this function, you'll notice that we do it. All right? We've done it this whole time. The only reason I'm bringing it up now is because this if statement has to have knockdown as the combo state. But the next if statement will be false if the combo state is knockdown, meaning it won't do this logic. But we still want to be able to buffer things from our input buffer and from our command list. So I recommend just setting this stuff up now. As long as you've been following the series, you should have at least have these booleans in here, and then you should know what they could be used for in the future. So we want to put this in anyway, even though it doesn't actually pertain to today's episode. If we left it out, it could cause issues or a little bit of inconvenience for players coming out of a knockdown state. else if they are facing right. So if the player is facing right and they are pressing or holding the right input, then that's a forward roll. They're rolling in the same direction that they are facing, that is forward. So we want to set our combo state to forward roll recovery. Now, remember, this else if is if we are holding the left input, pressing or holding the left input. If we are, we haven't released the left axis input. So we want to go ahead and set that to false. Then we want to do the same logic as above. So this time we're going to check if is facing right. Notice this one has an exclamation mark and this one does not. We're checking if we are facing right. If we are facing right, but we're pressing or holding left, this is going to be a backward roll recovery again, because we're rolling the direction opposite of the way we were facing. Of course, since this is the backward input, we want to go ahead and set is pressing backward to be true. Now, else, if we're facing left, essentially, or not facing right, well, we're pressing and holding left, and we're facing left, that is going to be a forward roll recovery. Those are our 4 conditions. Now, there's one other else. Like I said, this is an input axis. This is running every frame. So if we don't give it input, then we know for sure that we are not supposed to roll forward or backward. So what I do here is I just reset is pressing backward. Okay. And there we go. So this is all the logic we have to add to move right. I would highly suggest just copying this whole section that we had highlighted, scrolling down to your move right controller function, which is the same logic but for controllers. It does factor in dead zones and things like that on controllers, so it's slightly different. And just putting that whole block of highlighted logic in the same section. Okay, put it in the same section I put the other one. So I literally pasted it in here. If you want to factor in the same dead zones that the movement on the controller does, you'll notice we actually check for 0.20 as a hard-coded default. We don't have the ability to change this in options yet, so we just have a hard-coded value. You can go ahead and make that distinction now, just like this. Change the 0.01s to 0.20s. That way they have to be giving the analog sticks on the controller above that value in that direction. So we'll factor in dead zones and drifting. All right, with that said, we're actually done with all the code today. So now we can go into the editor and we're going to open up our animation blueprint. Okay, so first things first, there is one thing I want to fix in an event we have in the event graph. Just because we changed the logic for it, we never actually went back and adjusted it to work for combo states. Okay, and it's already here on my screen. You can see it's ugly. I'm going to fix it in a second, but I wanted to point this out. So if you're following the series directly, it's right around where your timers are. So the start get up timer, which forces the character to get up after 3 seconds of being knocked down. Invalidating the get up timer, which is if they've chosen to get up on their own. And the force get up, which sets the character state into recovery, eventually leading them to the idle state. Under that, I had something called end get up logic, which was resetting the character state to be no action, or essentially the idle state. However, this isn't really what we want. This was set this way because character state had all of these before we separated character state and combo state. And so we had to reset it back to idle. That way we could get rid of all the stuns and the knockdowns and things like that, and getting rid of the recovery state. But we don't actually need to reset the character state anymore. You could, if you want, force it back to idle. That's fine. There's really nothing wrong with this. But the important part is actually this right here. Okay. So I'm going to delete the combo state if it would let me. There we go. And instead of these reroute nodes, I'm just going to drag character reference directly into the combo state here. And combo state is the one we want to set back to no combo state now, because what we're trying to get rid of is if we're calling end get up logic, which we call either after knockdown, hard knockdown, or after some of these roll recoveries in some cases, We want to reset the combo state, not the character state. Okay, so you can get your character reference, say set combo state, and set it to no combo state. This is to resize the hurt box to the standard value that was already previously in the function. So you don't have to change that or add anything to it. All right, after that one minor graph thing is fixed, now we can go ahead and edit our animation blueprint. This is where we're going to actually make all of our roles occur. So the conditions in which we can roll, as we talked about already, are if we're knocked down. Okay, so if we're knocked down either on our back or on our chest and stomach, we want to be able to roll, but we have different animations for all of them now, remember? First thing we're going to do is add 4 new states. You can call these whatever you want. For some reason, I called knockdown front, front being the front of the body. So knockdown front is like the chest or stomach when you're on the chest or stomach. Just to prove this to you. This is the way the character falls. This is the knockdown state that refers to front in my NMBP. Okay. So this front is like stomach, chest. Knockdown, idle, stomach, chest. So I went ahead and kept that naming convention. If you see front, it's the front of their body that they're laying on. If it has nothing in parentheses, just knockdown, idle, roll forward, roll backward from knockdown. These are if the character is laying on their back. So, like this. This is the knockdown state for the character. Okay. So important distinction. The fronts are going to have their own animation, and the back are going to have their own animations. That's why we need 4 states. Go ahead and name them whatever you want. I called it roll forward from knockdown front, roll backward from knockdown front, and then roll forward from knockdown, roll backward from knockdown. Now, it's actually pretty simple to go to these states because once we're in knockdown, we just have to see if that enum ever gets set to our new values that we set, which are forward roll recovery or backward roll recovery. And that's how we can go from knockdown idle to each of the rolls in either direction. So let's start with the one if we are on our chest or stomach. So we have knockdown idle, front, going to roll forward from knockdown, front. First things first, notice it is not automatic rule based, but I do have a start transition event called invalidate get up timer. This is what we used here for the quick stand, because when we pressed up on the keyboard or up on our controller, when we want to stand up and we have the ability to do so because we were not hard knockdowned, we want to stand up at that time. We don't want to wait. If we were to not invalidate the timer here, it would actually call the function to reset the character state once the timer ran out, which could ruin a lot of things. It could screw up the logic the player is preparing for, could change this character state and cause them to bug out. We want to do the same thing for if we start a roll. If we want to start a roll, we don't want them to try and begin the standard recovery. So notice this is what's going to happen after 3 seconds if no input's pressed. The character is going to stand up on their own. Well, we don't want that to happen, especially after a roll. That doesn't make sense. Okay, so if we trigger a roll, we want to skip this state. So we have to make sure that on the transition to both roll forward from knockdown and roll backward from knockdown, in both cases, is going to have invalidate get up timer. Okay? All 4 of these state transitions that I just clicked on have that in the start transition event. All right. Now, on top of that, none of these states have anything on their actual animation state events, so you don't have to worry about that. The animations themselves, I have set up like this. You can look at mine if you want. I just basically disable looping for the 2 forwards. For the backwards, I did disable looping, and then I also set the play rate to be -1. This is because I only have that one animation, and so I set up all 4 of the animations that I'm using here for the rolls by just splitting that one up to different frames and reversing the play rate. If you have 4 different animations, then definitely use those, but I didn't, so I just played it in reverse. And then also make sure your backward animations don't loop either. Okay. And now let's look at our actual transition rules. So if we're looking at knockdown, idle, front. So basically, idle to a forward roll is going to be the same regardless if we're on our back or on our stomach. So we get our character reference, grab the combo state, and just see if the value from this is equal to forward roll recovery. Literally, combo state equal enum. Select the enum you want to check against, forward roll recovery. If it's true that the character's combo state is equal to that, we go immediately into the roll, and we're good to go. Now, alternatively, if we're pressing the button to go into the backward roll recovery, and the combo state is able to actually be set to that, then this will be equal, and we'll do a backward roll. Actually the same for the other knockdown case. I'll show you. Knockdown idle to forward roll from knockdown. And same for the backward. Alright, so you basically have two of the same transition rules. If you're having the 4 animations like I am, you could set shared transition rules for both the forwards and both the backwards. So you could have 2 rules that are shared between those if you'd like. But that's honestly simple enough. And then all of them have to transition back to idle. So to transition back to idle, I have transition rule on all of them. The forwards, in my case, are automatic rule based. So basically, once this animation is complete, it will just transition to idle. It's that simple. However, the backwards for me are a little bit weirder because if I am to play the animation in reverse, the automatic rule based, which is this automatic rule based on sequence, player, and state right here. Again, both my forwards, they have it set to true. My backwards don't, because if I have the play rate as -1, that's actually going to fire immediately. It's going to see that the time that animation is starting is at the end or close enough to the end that it wants to blend out of it. And so it's basically going to skip the backward animation. We can get around this with a minor adjustment. Instead of making it automatic rule based for the 2 backward roll to idle cases, what we can do instead is make our custom transition rule. And there's something easy we can do, and that is we can grab time remaining ratio. You can also do the standard time remaining, but I like the ratio. That way if the times of the animation change, or if there's time dilation, different things like that, it can make it a little bit weird, and you might not be exactly sure what value you want. If you use the ratio, you always know this is how much of the animation I want to be remaining before I transition out. In my case, I'm going to use 0 anyway, so it doesn't really matter. But we just want to type in time remaining, like I said, ratio, and you want to make sure this is the name of the animation for this state that we're transitioning from. Okay, so we're going from, let's look at roll backward from knockdown front, has the mutant recovery roll B2. So if I look at that, this is the line right here. Okay, this is the transition rule from that to idle. So if I click into this, you should see that I have mutant recovery roll B2, just as we expected. Now I can check if this value is less than or equal to a given value and pass into the result. So time remaining ratio determines how much time is left on that animation before it is done. And so this is really helpful because if we just check and see if it's less than or equal to 0, that means that the animation has completed. You could actually bump this up and give it a little bit of, you would essentially give it blend time. Say 0.2, if it gets within 0.2 seconds of completion, it'll start the transition to idle. Okay? But with keeping it at 0, we're saying once this animation is done, we can go into this. Even though it has a play rate of -1, it does still have this same time forward and backward, so the time remaining on the animation stays the same. Thus, this will give us a successful backward roll to idle transition. And the same is for the other backward roll, just to show you, just like that. Note that if you do a direct copy, you could actually get messed up here because the time remaining has to be on this animation. So I'd recommend, you could copy it, that's fine, but I would definitely recommend double checking, making sure the animation name here matches the one from the state. So this one's not B2, this is mutant recovery roll underscore B. And you'll notice that that is correct because it's coming from this state, which is mutant recovery roll underscore B. All right, one final thing we have to account for here, and that is what happens when we wrap up this state. Remember I was saying earlier we had this end get up logic that was resetting our character state. Well, now we're setting a combo state back to default. We need to do this because otherwise our combo state is just going to remain in the roll states, the forward or backward roll states, and we don't want to leave it like that. It'll prevent us from doing things in the code, in the logic later. Okay? So what we have to do is on each of these, all 4 of these, when they're returning to idle, here are my 4 transition rules, I put an end transition event of that end get up logic that we have in the event graph here. So just make sure your line, your names match up here, and then you can go ahead and apply this to all 4 of those. And when you transition back to idle, it'll reset the combo state and you'll be as good as new. Now, something I'm not going to be covering in this specific episode just because of how much work it would actually be is all the stuff that you can do with the, you have to, since we added new enums, there are certain things we don't want to be able to do while we're in that combo state of forward roll recovery, backward roll recovery. I don't have specific cases here. If I can do it with a combo state other than none, I can probably do it during these rolls, but fighting games get so incredibly complex that specific actions often can be done during other specific actions. So just be aware you may want to check your code and add these enum values in and check and make sure that you can only do certain things like jumping if you're not under the roll recovery enums. Again, alternatively, just check and make sure that the combo state is equal to none, and then you don't have to worry about any of these other ones. But I wanted to mention that because it is specific to everyone's game, so depending on what you have your logic set up as, you may need to do that. You may need to specify. The data table here, we have a data table of the mutant hitbox data. Make sure that the attack you're going to test this logic with doesn't have should cause hard knockdown. Because if it does cause hard knockdown, then you're not going to be able to do roll tech. That's intentional, that's by design. Remember, we only check the regular knockdown state. If you want them to be able to do it from the hard knockdown state, that's different. But if you're excluding them with it, make sure you're hitting them with an attack that does not cause it. You see, I do have some attacks that cause hard knockdown, like this throw right here. And from this throw, they won't be able to actually roll. So anyway, guys, that's all I got. So thank you so much for watching. If you enjoyed, please subscribe. It does so much for me, and it's completely free. I'd really appreciate it. I also want to give a huge shout out to my YouTube membership and Patreon members and supporters. Thank you guys for all the love and support. I am really grateful for that, and that helps me so much more than you know, and it gets me excited to work on these videos week after week. I love this series, I love this community, and I'm glad you guys are just as excited about it as I am. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. It is completely free. You can join and we'll be happy to assist you with any of the problems you had, get you going and back on the right course to be working on your game. Anyway, guys, like I said, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.